Okay. I believe we've got that to work. I'm just gonna go to here. Well, actually, maybe I should. Okay, hold on. Before I do it that way, I want to try playing my music, and then I'm gonna go to the channel and make sure that it's not playing the music. Okay, good. It's not coming through, so I can continue playing my music while we do some homework. And reason for the stream though is because wait, hold on, it says I need to sign in. Oh, okay, that worked. Cool. So the reason for the stream while I'm doing my homework is so that I can kind of talk out loud. I have like a study group that I usually study with, but when I do it this way, I can look back on it and see what my thought process was, and if it was a wrong thought process, then I can remember not to do that in the future. Anyways, this question here, we have A equals ti plus cosine tj plus sine tk, and then B equals I plus sine tj plus cosine tk. In calculus 3, we know that these are vectors, and so we have an A vector and then the B vector. I, j, and k are kind of just representations of the x, y, and z, a, b, and c. Yeah, it's really easy. So I put them here with the I, j, k. Maybe I'll highlight those in yellow. I, j, and k right there. And then when I was defining what C was, which is going to be our third vector, because we already have the A vector and the B vector, so I created the C vector. The way to create that is that we start with I, and so I, and then we ignore everything that's in line with I, and so it's just this here for I. But you go multiply across, and then minus the first one by the second one. So we get cosine squared t plus, and then it'd be minus, but because this is a negative, that's a double negative, so it becomes positive. So it's cosine squared t plus sine squared t, which I think we all know is 1. Well, yeah, because of trig identities and all that. So that means for C, it's technically I minus and then j and k, whatever the j and k have. But you can see that I've done all that here. The reason for the highlighted red is because I'm pointing out things that cancel immediately. And then we're left with 1 plus, and then I'm going to do another trig identity. We're going to pull out the -1, and it's going to be sine squared t plus cosine squared t, and that's 1. So this is 1 minus 1, which is 0. And when it's 0, we know the cosine of 0. Well, hold on. We know that the cosine of 90 is 0, which is what we're looking for. So we're trying to define if it's orthogonal between A, B, and the A cross B. I wonder if I could... I want to show you guys the Desmos. So let me create a new thing here. I think I can do that, right? Hold on, I'm gonna cross out of a couple applications. Okay, so I'm gonna create a new, what am I making? Media? I don't think it's media. Screen capture? Sure, and then we'll call this one Desmos. Whoa! Not what I want. Is there a way that I can kind of turn this off? Because I want to see it, but I don't want you guys to see it. Does that make sense? I don't know if I can do that. Okay, that one worked. But now my concern is, if I were... Oh, wait. Aha! So I can edit it. Okay. But my concern is now, if I did that, yeah. I want it to stay on that one. So window capture, and then Google Chrome. Somehow, Desmos. And then, yeah, there we go. Okay, so I'm just gonna put, whoa. It probably looks a little weird how I'm doing this. So I'm gonna put it there, and then I'm gonna bring me above. Okay. That way I can turn it off and on. Okay, cool. Well, you guys can see like the last one that I was working on. So let me graph this new one. Oh boy, this is kind of a complicated one. So I'm gonna get rid of that math because we don't need that. I'm just looking at the vectors right now. So all the vectors start as 0, 0, 0. So I'm gonna label it like that. Yeah, A, B, C. So A has T. Well, I need to add a slider for T. We'll just keep T to 1 for now. And then cosine T. And then sine T. Okay. And then, oh, wait. I did that wrong. I'm going to copy that and put the 0, 0, 0 back. And then put that on the other side. There we go. Okay. Next, B has the I. No. I is 1. So 1, comma, negative sine T, comma, cosine T. Okay. And then our C vector, the one that I made, is 1, comma, negative cosine T. Well, it's negative T times cosine T. That is right, yeah. J, T times cosine T minus sine T, yeah. Minus sine T, comma, negative t sine t minus cosine t. Okay. So we can zoom in here, and if you guys can see, like, let me see if I can organize this. There's like, oh, like there is a 90-degree angle there, and then there is a 90-degree angle there. So it's all we're proving is that this purple, the C, is making a 90-degree angle to both A and B. So I'm going to turn Desmos off. And since I proved that, I'm going to write it down. Both are orthogonal. Okay. Find the vector not with determinants, but by using properties of cross products. Okay, let's define a few things. So we know I is 1, 0, 0. Oh wait, I. And then we know J is 0, 1, 0. And then we know K is 0, 0, 1. Okay. So if we're doing cross products, we're doing that same thing. It's kind of interesting. So I think we just need to cross I and J first. So let's write it this way. I, J, K. And then we have the first vector, which is 1, 0, 0, and then the second vector, which is 0, 1, 0. And so the cross between those two become the vector I, which is 0 times 0 minus 1 times 0, so it's 0, comma, and then J, which is 1 times 0 minus 0 times 0, which is 0, comma, and then K, so it's 1 times 1 minus 0 times 0. So that's 1. Okay, so there's our first cross. And now that we know this is our I cross J. So now we can cross K with the I cross J. So we'll write this again. I, J, K. And then we'll use this one as our first vector, so that's 0, 0, 1, and then K, which is also 0, 0, 1. And so our vector is going to be I, which is 0 times 1 minus 0 times 1, so 0, and then J, which is 0 times 1 minus 0 times 1, which is 0, and then K, which is all zeros. So our vector is 0. This is like, when I'm doing homework, I'm like, is that right? Because it seems like too simple of an answer, you know? So I'm like, I don't know. But yeah, I think that's the answer, is 0, 0, 0, or just 0. So, okay, we'll go on. So I do my homework this way, and this is OneNote that I'm using to create, or not create, but do my homework. And then I also use it to do all of my notes. My only problem is when I go to like print it, which I don't think, oh yeah, you guys can. see how it like goes off the side. Like it doesn't print right. And I'm wondering, is that because I'm on a Mac or because OneNote just doesn't know how to print? And I've tried doing a million things like reset zoom, page width, everything. Even like in the print settings, I've messed around with that by where was it? There was a setting that I thought maybe would do it. Median quality, layout, and then I've changed like the directions and added borders and pages per sheet. Let's put that to like 6, and it packs everything onto the, like one page, but I want it. Wait. Did this one work? I think that one might have worked. It hasn't ever worked before. So, if it works, that would be great. I'm gonna hope that works. But anyways, number 16. The figure shows a vector A in the xy plane and a vector B in the direction of K. So find A cross B, and then use the right-hand rule to decide whether the components of A cross B are positive, negative, or 0. Okay? And the magnitude of A is 3, the magnitude of B is 2. Okay? I'm just thinking about it. Hold on. Okay. So let's just define a few things. We know our vector, well, whoa. We know our vector B is 0, 0, 2. Because this goes up a magnitude of 2, and because there's no x's, there's no y's, when you take the square root, or the magnitude of this, it would be square root of 0 squared plus 0 squared plus 2 squared, which equals 2. So we know that works. For our A vector, that's going to be a little bit tougher to find. We know that K is 0, but I and J, so we need it to be the square root of 9. And it has to add together somehow. And they should both be positive. So what's oh boy. 2 squared is 4, but then you need 5, and you can't get 5 by squaring anything apart from an irrational number. Unless you took the radical of 5 and squared that. That would technically work. So if we did 2 comma radical 5 0, that technically works. I don't know if that's what they want us to do, though. Okay, and then we also need to define what the right-hand rule is. Calculus 3. So the right-hand rule is a method used to determine the direction of a vector resulting from a cross product between two vectors. So point your index finger in the direction of the first vector, curl your fingers towards the direction of the second vector, and then your thumb will now point in the direction of the cross product vector. So A and then B and then C would be the thumb. I don't even know if you guys can see. Oh, yeah. Like, yeah, that, I don't know. That's kind of weird to me. Okay, when I am stuck like that, I usually just come here. So let's put our B as the 0, 0, 2. And we gotta flip this back right side up. And then we'll turn the C off for now. But we're gonna see if this technically works. Yeah, I mean, it's basically where it is. And its magnitude, oh, whoa, that's spinning. And its magnitude is technically 9. Wait, no, 3. My bad. Yeah, magnitude is 3, which is supposed to be, because it would be 2 squared, which is 4, plus radical 5 squared, which is 5. 4 plus 5 is 9. Radical of 9 is 3. So that's what we want. So both of those technically work. So in a way, I guess we do. You would think about what it would be like. But only problem is if you cross these, you're just going to end up with hold on. Okay, let's try and cross it. See what happens. Because if I got this right off of just like kind of guessing with that radical 5, I'm going to be kind of happy about that. So we got to get our I, our J, and our K. So first we got 0, 0, 2, and then we have 2, radical 5, 0. So that gives us I, which is 0 times 0 minus radical 5 times 2. So that's negative 2 radical 5, comma. Well, hold on. I'm going to put it here and make it equal to C. So negative 2 radical 5. And then J, which is 0 times 0 minus 2 times 2, which is negative 4. And I need to make sure we know this is a vector. And then K, which is 0 times radical 5 minus 2 times 0, which is 0. So there is our third. So if we bring Desmos back, and then we can take this out, this long mess, and then do negative 2, radical 5, comma, negative 4, comma, 0, and then turn that on. Interesting. And it's a lot bigger than the other two as well. So, okay. Let's say we point this and then that. I don't know if that really follows what the right hand rule is supposed to be. Wait. So there's our first, well, let's say there's that, right? There, and then there, which means it would be going down. No? Because it, like, if I can make the right hand fit this way. But if I do pointer finger at A, and then those fingers there at B, then it technically points down for the right hand rule. I don't know about that one. This is a weird song that's playing. But I realize you guys can't really hear it, so I'm just gonna skip it. And wait, and what's even the question? Find A cross B, okay. Well, A cross B is here. I mean, I kind of made up A though. No, yeah. I kind of made up A. Does it make a difference if, because I wonder if it makes a difference if we switch the order of these. So if well, hold on. Whoa. Okay. If I erase these and then push, well, I'm not doing this in the best way. So, okay. If I take a lasso and put those below and then take another lasso. Oh, take the other lasso and move them all up. Will that change? So I is 2 times square root 5, comma 2 times 2, which is 4, and then 0. So it's just positive instead. Are you guys still looking at Desmos? Oh yeah, my bad. Anyways, we can just get rid of the negatives. And we get that. Okay, so there, wait, there, oh, there. I don't think that's right. So either I got it wrong or something else is at play here. I forgot my password to something. Two-step verification is like, it's nice that it's like secure and stuff, but it's also like crazy annoying that it does that. Tap yes on my phone or tablet. Come on. Yes, it's me. Oh my goodness, dude. Come on. There we go. Okay. I'm looking stuff up, trying to find more information. It's probably more simple than I'm trying to make it. Because I am kind of assuming with the radical 5 and the 2. So I'm opening my book, going to 12.4 cross product, and then I'm trying to find the homework problems and maybe some examples. This is problem, what problem is this? 16. This one's saying I need to use sine theta. Well, hold on. Let me bring you back here. So I know, because this is just on the z-axis and this is just on the xy axis, that this is a 90-degree angle. So cosine of theta is going to be 0, and sine of theta is going to be pi over 2, right? I know that. But why do I need to use that? And it's saying something about like the cross between two magnitudes is just timesing them together. But and this is Google, not the book. So I'm a little confused on that part. Maybe I should actually look through the book. Oh, found it. It's talking about torque, but hold on. Okay. I'll copy this into here. So torque, or well, we're just gonna ignore the torque part. So do you guys see that? How it's the magnitude of R cross F equals magnitude of R times magnitude of F times sine theta. So we can just use that. We don't have to lay it out like I had it. So I'm just gonna erase everything. Don't you love that? Doing all that work and then erasing everything. So we know A cross B magnitude equals A magnitude times B magnitude times sine theta, which equals 3 times 2 times sine theta, which theta between them is 90 degrees. So that's pi over 2. Oh, 2. Which 2's will cancel, so we just have 3 pi. So what does that mean? What does that mean? And then use the right-hand rule to decide whether the components are positive, negative, or 0. I'd say it's 0. Because, well, no, maybe it's negative. So, okay, if we have 1 pi, we go, so 1 over, that's negative. Well, negative cosine, but 0 sine. And then back to 0, and then 1 more pi, and we're back in that negative cosine, 0 sine. So I don't know what to do here. The right hand rule really, it doesn't make any sense to me. I don't think my hand moves that way, which is strange, because like my hand moves pretty good. I play piano and such, but for some reason when it comes to weird stuff like this, it's like nah. Oh wait, but well, no. So just using my hands, it's like, okay, it's probably negative, but I don't think it is. Wait, sine of 90. Oh, I was thinking radians. Sine of 90 is 1. So that's 6. Okay. But so when it says components of A cross B, I think it's talking maybe that we need to decide each X, Y, and Z on its own. So like X is something, Y is something, and then Z is something. I'm thinking maybe that the cross would kind of go that way. Like that way. Oh man, I'm not used. When I do these like live streams, I don't usually have the camera on, so this is kind of strange as well. But I don't think anybody's watching, so it's probably fine. You know, yeah. Unless I just boop, there you go. I'm going. Ah. Yeah, no, I'll leave it. It's fine. Oh, okay. I think I've maybe figured out a way to do it. So if we do the cross that we were initially going to do, I'll do it in black. The I, the J, the K, and then we just use something to represent it, then let's see, what could we use to represent it actually? Well, for A, let's do A first. We know that we have an X, a Y, and then 0. And then for B, we know that we have 0, 0, 2. So then when we cross that and we get our A cross B, I guess we should be drawing vector symbols above all these, but it doesn't matter. Not right now. For me. It does matter, but yeah. Anyways, I is going to be 2AY, and then we'll have a minus, and J is going to be 2AX, and then K is going to be 0. So that's our cross there. So if we kind of leave it like that, or technically, let me move things over. Technically, this should have an I, and then this one should have a J, and then this one a K, right? Then we know that I is positive, J is negative, K is 0. I think that's gonna be how I have to leave it. So I positive, J negative, and then K 0. And that kind of works if we go this way, right? Because we'd have a positive, well, no, that would be a negative X. Not if we go this way, though. So positive X, negative Y, and 0. So that's where we're going to leave it. It's just, yeah. Because I don't want to spend too much time on each question, you know? So I'll bring this one up. Sorry, singing or humming to the music. So A cross B, we'll have our I, our J, and our K. So 2, negative 1, 3, and then 4, 2, 1. So then we have a vector of negative 1 minus 6. So negative 7 I and then comma J would be 2 minus 12, so that's negative 10 J, comma 4 minus negative 4 is 8, and then K. Cool. So then we go B cross A, we'll bring in our same I, J, K, and we'll have 4, 2, 1, 2, negative 1, 3. And so this equals a vector of 2 times 3, which is 6, minus negative 1, so 7. I'm pretty sure it's going to be the exact same, just reverse signs. But I'm going to just double check. So we have j, which is 12 minus 2, so 10, yep. And then k, which is negative 4 minus negative 4, or minus 4, yeah. So negative 8. Okay. That was easy. 19. Oh, my neck's starting to hurt. Find two vectors, two unit vectors orthogonal to both 3, 2, 1 and negative 1, 1, 0. Okay. Well, so we're going to use something called a thing. Hold on. We need to make sure that these are unit vectors first. So let's call this one A and this one B. So the magnitude of that one is going to be 3 squared plus 2 squared plus 1 squared, which equals 9 plus 4 is 13 plus 1 is 15, so square root 15. Okay, and then magnitude of B is going to be square root of negative 1 squared plus 1 squared plus 0 squared, which equals square root of 2 squared, of 2, square root of 2. So, hold on. Hold on. Need to use a passkey or something? I don't like that thing. So I'll just do it that way. Okay. Well, I need to preview, maybe go back here. Or is it this one? This one I was having so much trouble with, but we finally got that one. I'm trying to remember, like, in order to make something a unit vector, do you just times it or do you divide it? I think you divide it, but I want to see like proof. I know I've written it down somewhere. Or not written, but like I've done it before somewhere in here. It's crazy because I feel like I'm super organized until I need to find something very specific. Maybe if I go to the book. Search unit vector. Yeah, you divide. Okay. Woo! So go back here. And so how do I find just two random vectors? Because scaling them with that will turn them into a unit vector, but it's not going to make them orthogonal to them. Because I'm thinking we use the rule that cosine theta equals a dot b, right? So do we just a dot b, and then there's a vector? Oh, and then we could do b dot a. Yo, am I stupid or a genius? Okay, hold on. I'm gonna try that and make sure that it works. So if we're going for orthogonal, then we need cosine of 90, which is 0. So we'll do 0 equals a dot b, which will do that. So that'll be -3. Oh, wait. When you dot it, it's... Wait, the dot... Dot product creates just one number, not a vector. So A cross B, right? A cross B, and then B cross A. I think that's what we need to do. So we get our I, our J, our K, and we have 3, 2, 1, -1, 1, 0. So that's C equals the vector, the vector, 2 times 0 is 0, and then -1 times 1, so -1, comma, I don't know if that's going to make it... Wait. Are these orthogonal already, just because you crossed them? I don't think so, right? I really don't think so. But is it? Maybe it is. Wait. It is, right? Why am I brain farting right now? Okay, I guess we just make this and then we prove that it's orthogonal, right? So -1, okay, and then j is 3 times 0 minus -1 times 1, so 1. And then 3 times 1 minus -1 times 2. So that's 3 plus 2, which is 5. Okay, and then we'll do it again for D. Well, maybe I should prove that this one's. So A dot C equals 3 times -1 plus 2 times 1 plus 1 times 5. So that's -3 plus 2 is -1 plus 5 is 4. So that's not orthogonal. Okay, I need to. Did I do something wrong? -1 times 3 plus 2 times 1 oh. If I rescale it, that's not gonna change it, right? Okay, maybe I did this wrong. Two times 0 minus 1 times 1, and then 3 times 0 minus negative 1. That's positive 1. And then 3 times 1 minus negative 2 is 5. Oh. I know what I did. Okay. Is because the second one is supposed to be a negative, whether you like it or not. Okay. So let's see if that, yeah, because that would be a negative 1 here, and that becomes 0. So it is orthogonal. Okay. Now we can test the next one. So B cross A. So we have I, J, K. Then I need more space. Just a few more lines. Negative 1, 1, 0, 3, 2, 1. And then I'll show you, if anybody cares, or if maybe Future Hunter cares, why that one needs to be negative. That is because of reasons. It's just because it, like, it's supposed to be I minus J plus K. Just for whatever reason. That's why. Okay? So I is 1 minus 0. So we're going to make this D. So 1, comma, and then it's going to be a negative. But we have negative 1 minus 3. Wait, 0. So because it's negative 1, it's going to be a positive 1. And then we have negative 2 minus 3, so negative 5. And then that's literally just the opposite, just different signs. So it will definitely work, but we're just going to check it, just be sure. Oh, actually, I need to make sure it's orthogonal with B as well. So I'll do that here in a second, but I'm going to do A dot D and then B dot D. So, okay, now I'll just work my way down. So we have negative 1 times negative 1 plus 1 times negative 1 plus 0 times 5. So that's positive 1, negative 1, 0, 0. Okay, so that's orthogonal to both of those. That's good. That's good. So A dot D, what song is playing? That's good. Casita by the Astronomers. Cool. Okay, a dot d is 3 times 1 plus 2 times 1 plus 1 times -5. So that equals 3 plus 2 is 5, minus 5 is 0. So orthogonal. Oh. Ooh. I just got a notification for an engineering student intern. Interesting. I'll look at that later. So b dot d is going to be -1 times 1 plus 1 times 1 plus 0 times -5. So that's 0 as well. Okay. Now, only problem we have left is I don't believe these are unit vectors, right? Because if we get the magnitude of c, it's going to be -1 squared plus -1 squared plus 5 squared, which is 1 plus 1 plus 25, which is square root of 27, right? And then if we do that same thing for d, it's literally the same thing, huh? Yeah, 27. And so, in order to get it, we need c to equal root 27 times those. So we're just going to put it in there just to be sure. Over root 27, comma, -1 over root 27, and then 5, over root 27. And then I'll highlight that as like our answer. Whoa. If I can go straight. Hold on. A place where I can go. Take this off my shoulders. Tell one, take me home. I have a feeling that's not going to work. Why do I feel like that's not going to work? I'm going to type this into my really long into my calculator. Wait, why I have Desmos. And I'll just let you guys see it too. Okay. So we need the square root of, Okay, so it's going to be -1 over root 27. Plus, same thing, right? Yeah, -1 over root 27 plus 5 over square root 27. Somehow it works. Why does it work? Oh, I'm an idiot. It's because it becomes 27 over 27. Yeah, and so it's just the square root of 1. Okay, cool. I don't know why I was just like, this doesn't work. I don't know. I do not know. Sometimes I'm just a weirdo. Okay. So that, let me just do this. So D, nope. 1 over root 27, 1 over root 27, 5 over root 27. And then highlight that. I really want to know if I can just like print this into like PDF form so that my teacher can just like accept this as the homework. That would be great if he could do that. Let's see how it's looking so far. If we put it the layout to the 4 pages that we did before. I think that should work. To be honest, I think that should work. I might have to put like a little bit of space in between problem 16 so that it pushes it to the next page. Wait, page view. Wait. Oh no, it's back to sheet view. So what does page view do? Sheet view. Okay, hold on. I'm gonna try this real quick. If whoa, no, I don't actually want to print it. Hold on, I don't actually want to print it. I just want to save it as. Can I not just save it like that? File, save as PDF. Doesn't give me all the customization. It might not work, to be honest. Why can't I have all that information when I save it as a PDF? Okay, I'm gonna save it to my desktop. And then see what it looks like. Yeah, it looks like crap. Oh, that's so annoying. Why does it do that? Okay, I'm gonna delete that. Okay, hold on. I need to go to the bathroom. Bathroom break. You guys can just stare at my homework for a second. We'll go down to the last problem in case you guys want to see that. Okay, I'm back. Whew, quick break. Okay, find the area of the parallelogram with vertices A, B, C, and D. Okay. I think we should go here and graph those. So we have A at -3, 0. A equals, yeah. And then we have B equals -3, -1, 3. And then we have C equals 5, 2. And then D equals 3, -1. I mean, it's just a, wait. It's just a square. I guess that's what a parallelogram is. Oh man, sometimes I'm special. So let's go back here. So the area of a square, can anyone guess what the area of a square is? Base times height. Yeah. So because we have a parallelogram, the only hard part is going to be figuring out the distance between them, but it's really not that hard. Well, okay, it should be pretty simple. So let's see, we have A, B, C, D. Okay, so let's get the distance between B and C. So the distance formula is the square root of, let me see if I can get this right. I think it's x1 minus x2 squared plus y1 minus y2 squared. And then I'm going to Google it just to be sure. Looks like people usually put like x2 minus x1, but it doesn't matter. You square it, right? You square it. It doesn't matter. You square it. So, okay. We're going to do AB first. So x from A is -3, and then minus x from B, which is -1, and then square those, and then add the y's to do both of those. So y of A is 0, minus y of B, which is 3. Okay, and so that equals the square root of -2 squared, which is 4, -3 squared, which is 9. So that's the square root of 13. Okay, now we just get BC, And I'm gonna probably just go silent and do it. So the area then becomes square root 13 times square root 37. That's easy. Oh. Okay, now I really want to find out if there's a way that I can get it to be how I want it to be. Oh wait, I can save it as a PDF here? Oh, okay. Hold on. So let's do use last settings and just confirm it. And then I think if I go here to 16, yeah, and add some extra space. Yes. Homework 3, section 12.4. And then save that to my desktop. I think that may have worked. Hold on, it looks a little different. So I'm just gonna start at the top and okay, why is that? Okay. Oh, it cut off a little bit right there. Why does it do that? Okay. Well, I need to add a little bit of room right here then. Use settings. Is there a way that I can remove space now? Because I think I have too much space in between these. Remove space, OneNote. And are you guys, yeah, you guys are here. It says I can, oh, okay. So we're just gonna put it like right there. Okay. Last use settings. I think I'm going to email the teacher and see if he would accept that. Wait, what's up with that one? That's 16. 16 still looks weird somehow. There's just a weird like dot in the middle of it. But that's okay. Wait, 19 looks really weird. Yeah, 19 is doing that weird like cutoff. Why? Fix pages in OneNote. This is kind of just troubleshooting. I'm not even doing homework anymore. Like I finished this homework. But I still have the 12.3, but I need to figure that out. Okay, wait. View. Yeah, it's like it's cutting off on 19. Like it's cutting it right here underneath the B. So I think I could probably fix that if I just insert a space to there. And let's see what that gives. It looks like that one worked. So I'm going to turn that into a PDF again and open it in big view so I can double check it. Okay, I like it. I'm just gonna email my professor and be like, hey, would you accept this or should I still write it on paper? You know? Actually, I'm gonna make sure all the questions are on there. So I need 1, 4, 6, 9, 16, 17, 19, and 27. Okay. I'm going to email my professor now. Okay, I'm saying, hello, professor, and then their name. I have a question about the format in which homework is turned in. Thus far, I do my homework digitally in OneNote and then write it down on a piece of paper and then scan it back to digital to turn it in onto the site. I gave the name of the site, but I don't know if that matters, but whatever, I'm going to say it on YouTube. Today, I found a way to convert the OneNote to PDF. I have attached it to this email. My question is, will you accept this if I turn it in this format? Thank you. So, just need to make sure I'm consistent. I think I'm going to do Microsoft OneNote, just so he like for sure knows what I'm talking about. Okay, and then I'm going to attach it. Oh, I should probably write my name on it, huh? Here. Just gonna write my name. And then do it one more time. Okay, just previewing it one more time. Nothing looks broken. Okay. I'm like nervous. I keep checking it over and over and over before I turn it in. Even though I'm not turning it in, I'm just sending it in an email of like, hey, would you accept this? Okay, I sent it. I sent it. I sent it. And now, I think what I need to do is probably go outside or something. It's 3 o'clock, and all I've done is homework today. I guess I ran into work for like an hour. I work on campus, but I ran into work because they needed somebody to cover the shift. Thursdays are usually my day off, where I get to do nothing but homework so that I can catch up on everything. But they needed somebody to cover, so I ran in and did that for them. So, yeah. Anyways, I think that'll be it for this live stream. I got to figure out how to do 12.3. Because that one, for some reason, is not making any sense. Like, here, let me see if I can... In the off chance that somebody actually watches this, how do you answer this question? Find two unit vectors that make an angle of 60 with the given vector 3, 4. I worked it out on a whiteboard forever, and I had another person in the class working it out with me in their own way, in a different way, and they couldn't, like, neither of us could figure it out, and we were like, what? And then I've asked Google, and then I've even asked like AI, like, what the hell am I supposed to do here? Sorry, I probably shouldn't swear, but like, what do I do here with this? And AI was even like, I don't know, dude. It kept giving me answers, but every time that I took their answers and converted it back into the angle, it was like 62 degrees, or even like really far off, like 40 degrees. And I'm like, you guys aren't getting it. So, I mean, AI is great and all, but you should definitely double check the work. Like, plug it back in and all that. Like any time that I've used AI, it's not a like just give me the answer so that I can get it done. It's definitely like a, hey, I it's like I did it and I need to double check, or I have no idea what's going on, please help. And I always double check. And this time I double checked and I used like 3 different AI models and all of them got it wrong. So if somebody by chance watches this, the end of this live stream, please, how? How? Anyways, okay. That was my spill. Thank you for watching if you did. And goodbye.